All right, numbers 1 through 4 here ask you to determine whether the polygons are similar. It says, if so, write a similarity statement and give the scale factor. So we're going to look at some other problems as an example, and then you guys can work on those 4. So here we have triangle RSQ and triangle UXZ. And so we're going to look to see if they are similar or not. So in order for the triangles to be similar, or for any polygons to be similar, we need 2 things. The sides need to be proportional, and the corresponding angles need to be congruent. So let's first look at the sides. If they're proportional, right? If the ratio of the corresponding sides are going to be equal, the largest side is going to match up with the largest side, and the smallest with the smallest, and the middle with the middle. So if we look at 35 here, it's going to have to match. It's the largest, so it's going to have to match up with 40. So we can say our ratio for this set of corresponding sides, RQ to UX, right? And we can write that out. RQ is going to correspond with UX. Okay. The smallest is 21 and 24. So if they're going to be similar, the smallest side here, SQ, okay, is going to have to line up with XZ. So those sides will have to, the ratio will have to match up. And then RS is going to have to match up with the middle length is going to have to match up with the middle length. So RS is going to have to match up with ZU. Okay, so let's substitute in those values. So RQ is 35, so we have 35 over 40. Okay, we have SQ here is 21, so we have 21 over 24. And we have RS, 28 over ZU, which is 32. So 28 over 32. Okay, if we reduce this, we can divide the numerator and the denominator by 5. If we divide by 5, we're going to end up with 7 over 8. Okay, divide by 3 here, the numerator and the denominator, we're going to end up with 7 over 8. And then here we divide by 4, and the numerator and the denominator, we're going to end up with 7 over 8. So the ratio of the corresponding sides are going to be equal. So that means that the sides are proportional, so we're good there. Okay, then the next thing we have to check is our angles. So let's look at our angles. Okay, so we have angle S is a right angle, so it's 90 degrees. Okay, so it's going to correspond with angle Z, which is 90 degrees. So since they're both 90 degrees, angle S is going to be congruent to angle Z, meaning they have the same measure. The 3 angles of a triangle add up to 180. So if we were to do 180 minus 53 minus, minus 90 minus 53. Okay, that's going to be 37. Right, so our missing angle here, R, is going to be 37. 3 angles of a triangle add up to 180. And we can do the same thing for this one, right? So we have a 90-degree angle and a 37-degree angle. So we can do 180 minus 90 minus 37. And that's going to give us 53. Okay, so we have this angle here is 53 degrees. Okay, so angle S is congruent to angle Z because they're both 90. We know angle Q is going to be congruent to angle X because they're both 53. And angle R is going to be congruent to angle U because they're both going to be 37 degrees. Okay, so we're going to say that yes, these triangles are similar. They're similar because, one, our sides are proportional, right? We have 3 pairs of corresponding sides that are proportional, and we have 3 pairs of corresponding angles that are congruent. Okay, so angles are congruent, sides proportional, so they are similar. So now our triangle similarity statement. We need to name the 2 triangles and say which triangles are similar. So you can name the first triangle however you want. So I'm just going to name it RSQ. RSQ. Okay, and we're going to say it's similar to triangle So we have to match up our pieces. So R is going to correspond with U. Okay. S is 90 degrees, so it corresponds with Z because it's 90 degrees. And Q is 53, so it's going to match up with X. So triangle RSQ is similar to triangle UZX. Okay. The next one, these are rectangles, so we can fill in our, they're rectangles. Okay, so the angles are pretty easy because rectangles are defined as having quadrilaterals with 4 right angles. So we know all of our angles are going to match up, right? They're all going to be 90. So we're going to have 4 sets of congruent angles, right? Because they're all going to be 90 degrees here. Okay. Okay. We know opposite sides of rectangles are the same. So 54, 54, 24, 24. So we can fill in those sides, right? Because they're rectangles. Okay. AD, right, is going to match up with ML. AB is going to match up with MJ. Okay, BC is going to match up with JK. And then DC is going to match up with LK. Okay, and then we can plug in those values to see if those ratios are the same. So 36 over 54. Okay, 18 over 24. Okay, 36 over 54. And then 18 matches with 24, so we'll do 18 over 24. Okay, we can reduce these. So 36 and 54. What do we think can go in both of those? 6 probably, right? So if we divide by 6, we're going to end up with 6/9. Okay, divide by 6 here, we're going to end up with 3/4. Okay, again, 6/9, so this actually reduces to 2/3, right? 18 will go into 36 twice, and 18 goes into 54 3 times. So this is going to reduce to 2/3. This will reduce to 3/4. So 2/3 and 3/4. Okay, so those values, those ratios are not equal. And since those ratios are not equal, the sides are not proportional, so we can say that the triangles are not similar. So if they're not similar, there's no similarity statement, and there's no similarity ratio. Okay, we missed the similarity ratio over here. That's just going to be the value here. So 7/8, right? So this one is 7/8. The smaller one is 7/8 the size of the bigger one. Or you could say the bigger one is 8/7 the size of the smaller one. Okay, so that's 1, 2, 3, and 4. You want to see if the angles are congruent and if the sides are proportional. And if they are, then they're similar. And then you write a similarity statement and give the ratio. If the sides are not all proportional, or the angles are not all the corresponding angles are not all congruent, then we're going to have to say no, the triangles are not similar.